Okay, so thank you, Hugo. Okay, so I'm Tiago. I'm going to present InSimo. So InSimo was more or less the first, one of the first spin-off company from INRIA that has started with SOFA. Now about 7 years ago, so it's quite an old startup, and we shouldn't maybe call it still a startup. And we are doing some, basically simulation software for surgical training and education. So really focused on only pedagogical simulation for surgery. So our story, we are really linked to SOFA, another time, but quite the same technology that has evolved. Today the company is about 20 people based in Strasbourg. As a spin-off from INRIA, we have had many different fundings to grow, basically, to work on our internal R&D stuff. Today we have about 4 active projects and product development, and I will show you a quick overview of these different topics. What do we do? Actually, this is the mantra of the company. For startup, it's important to have something that we really want to do beyond growing and making money. We want to foster the creation of the new generation of medical simulators, highly realistic. We think that so far today is the best technology to do realistic simulation stuff in a fast way, actually. So faster to develop, but also fast to have interactive simulation. And all of this is to allow some broader commercial use and novel offers. And when we have started InSimo, and I think it's still the case today, it exists some simulators, there are some, but most of them are not good enough to give enough content and realism to have a great impact on the way the surgeons are training right now. So we want to go further and provide some better solutions. As I said at the beginning, we are based in Strasbourg. So some people here come from the same place. In Strasbourg, there is what we call the EHU. It's a hospital institute, and we have designed. InSimo is born in area, and then it has been incubated in Strasbourg EHU. And in EHU, we have this medical expertise with many surgeons working there, and social partners, and also the academic world with a team of Stéphane Cotin, the consortium also. So we try to work everybody together, all together to do great stuff and to bring some innovation to this conservative medical world, actually. So what do? We have 2 kinds of applications. We work before surgery and during surgery. We work on surgical gesture training, so doing really the surgery and feeling with haptic device, for example, what the surgeon will feel during a real surgery. But we also work on the preparation of the surgery, what we call surgical planning, so before doing this job. I start with surgery itself. Our main project, so I think many of you already know this, but I will show a quite recent video later, is to develop this cataract surgical surgery simulator for what we call M6. It's a manual surgery, and we developed this for a US foundation. This simulator aim is to foster the training of thousands of surgeons in the developing country to fight against cataract blindness. So for this simulator, InSimo use SOFA, actually. We have started with SOFA, but then we have developed our own technologies, and we're working with industrial partners on the hardware part and on the rendering also software. This is a more recent video. I will let you see it a bit. So I've let the SOFA part so that you could see the different mechanical models that are in interaction, modeling this eye. This part is what we call the capsulotomy. So it's a very precise and delicate step of the surgery. You see, we're doing these tears, cutting and tearing of the capsular bag. So it's passing through this very thin tunnel here in the sclera. We go a bit later in the simulation, in the procedure. It's quite long. And then, after removing this capsular bag, you have to remove the nucleus, so the parts that have the cataract and that prevent the patient to see, actually. So you have some freedom, some freeze involved in the surgery, and you see this nucleus that is going up in the eye, and you will have to put it out and replace it with another internal intraocular lens. So you see all these steps. So it's a really, really, really advanced simulation, and we have worked a lot at InSimo to do some improvements in the technology for all of these cuttings and also on the performances, because dealing with this kind of simulation is really, really a bottleneck. You see the last part. This is a tricky part, actually. But you see, on the video, it's worked well. So it's passing this nucleus through a 0.3 millimeter tunnel that has been dissected in this sclera. So that was the first part of the surgery that you see in the previous slide. So this is our main project, and this has become possible, and it's still in development, because in this foundation you have a US billionaire that is funding a lot this project. So it's been a lot of years now that we are developing this, and we have started from a prototype that have been developed for years also at INRIA with many guys that are still in this room. And all these guys are coming from this American foundation, has been founded also by guys that are coming from the aircraft simulation, founders of aircraft simulation 100 years ago, and that they are trying to put the same effort today in medical simulation to come to the same standard of training that has been developed for years now in aircraft. We have also done some different simulation prototypes in collaboration with the SOFA community. On the left, it's retina surgery that we have developed with the team of Stéphane Cotin a few years ago, and on the right, something developed on aneurysm clipping, there with the team of Christian in Lille. All of these were prototypes, advanced prototypes, I think. For all these simulators, we have used the same hardware, and this hardware has been developed by MOOC. It's also a US company, but the guys that are working on these haptic devices are working in Netherlands. So I won't spend a lot of time on this. It's results, and it's stuff that we want to develop maybe sometimes products, because we think that we have good skills now in microsurgery. Next, I think you all know that robotic surgery is becoming a really new and becoming very big now. Many new robots are coming, and the intuitive Da Vinci robot is now used in many hospitals. We have a European project today with our partner Graphics. Graphics doesn't exist anymore, but the guys are still there. We are working to develop a common software offer for generic offer to be able to develop some new simulators for all this robotics company to train. Have time or? So in this topic, there is something that is quite an old project in the software community, working on the suturing model that will be really, that we feel will be better than the one that is available in all the simulators available on the market for the moment. So suturing is really a difficult topic, and surgeons are really not happy with this suturing that is available for the moment in simulators. So we have this collaboration right now with also the team of Christian and many engineers at InSimo, trying to do a really first suturing model in an interactive simulator. I think we're on the good path. Yeah, I hope we'll manage this time. And I think we are in the good way. And last one, it's a more recent project. It has nothing more to deal with surgery, but more with medical, with daily medical gesture. It's a more basic simulator, but it has a great interest to work for the medical students that have really soon in their study to deal with some gesture like the lumbar puncture. The lumbar puncture is quite risky procedure. You insert a big needle, not so close to the spine. So for that, we have developed a simulator with a basic haptic interface. So for us, for this kind of development, we not only provide the simulation part, but we try to build the whole simulator. So there are many different other bricks that we have to work on. So you have the biomechanical interactive simulation, of course. It's patient-specific in this case. We have the haptic interface and the control of it. For this project, we have decided to develop a mixed reality immersion. So mixed reality is the Microsoft name of augmented reality, but because we want to go beyond just learning the gesture itself, but as the patient is not sleeping for this kind of gesture, you have also to care about human care about the patient, to set him in a good position. There is a by-patient step. You have many things in the communication also, so we want to develop something with mixed reality that will use the simulation when we deal with not putting a real needle inside the people, but for all the other parts of the gesture, having real people inside the simulator. And you also have pedagogical elements that go with the simulation to give a full product. So yeah, these are the partners involved in this project. So it's a starting project, but I think it has a great potential. So last part, we go faster for that. It's all the work we have done for years now on surgical planning. So for all the other stuff that I have shown until now, we work on generic anatomy. So more or less an artist is creating the geometry of organs, and then we put them in the simulation. Here we deal with patient-specific data, so we start from the CT scans, we do segmentation and 3D reconstruction of the patient. We don't do that, but we have companies that do that for us. And then we add the simulation so far in our engine to build a 3D patient-specific deformable and operable model. So in the end, we have something that we can do virtual surgery on that. So what do we do with the simulation? It was based on the need that we have a need in the issue of Strasbourg. It was how could we decide which strategy, which surgical strategy to do on each specific patient, and see with the simulation what would be the consequences of each design. For example, on this example, we have a stomach, a dissection of the stomach of a part, for example, a tumor, and then the suturing. You have the impact of the parts that you are dissecting, but also the suturing direction, the number of points, and you see the final shape of the stomach and the final mechanical threads, and you can see it will have some different consequences on the patient in the post-operative phase. So we have built a tool that is for the moment a pedagogical tool to work on these different surgeries. So mostly for the moment on digestive surgery, but we see this as a generic surgical atlas on which you will be allowed to work on any kind of surgeries. So you do the design, the user is doing the design of his surgery and use the simulation, so powered by, so far, physics at InSimo, to see what would be the consequences of it and adapt his strategy for each specific case of patient that is inside the library of cases in the software. So this is the display software. Okay, I won't do this, but as you can see, there are many other things than the simulation. On this product in particular, we have spent a lot of time working on the UI of the interface to have something that is really user-friendly to use. So it's important for us. And you see the different kind of modules, surgical modules that are available right now. So you see these different videos. We have worked on bariatric surgery, so urology and also vascular surgery. So more or less of the modules are in development right now, but we have done some university courses on the two first of them. So we have proved that students can learn stuff with that. So now we are trying to sell it on the university market. So finally, InSimo now works on two kinds of application, surgical gesture training and high fidelity generic anatomies, but also surgical planning on patient-specific cases. So in the end, our aim is to provide some real source simulator trying to make the connection between these two areas and propose some simulator on which you will be able to do the rehearsal of a real procedure. Thanks.
And because I actually forgot to set up properly the table, there should be, I think, also a demo, which was actually already available a bit at lunch. But on the third table that has just been set up on the left, you could try, I think, a part of the display product that has been presented by Pierre-Jean. Is there any question? I saw a lot of photos taken during the presentation, which is good. If you want to discuss, ask further questions or whatever, yeah, it's HDMI magic. If you wanna add further questions, I mean, well, right now obviously, and if you're too shy or if you think about some additional things later on during the break. Thank you again, Pierre-Jean. Yeah.